Students, this is a beautiful question. We expected to find the value of a and b given that square root of cos cubed x over sine raised to the power of 11x times dx is equal to negative 2 times of a times tan raised to the power of negative 9 over 2x positive b times tan raised to the power of negative 5 over 2 times x positive arbitrary constancy. So this is a beautiful question. So foremost I will consider the left hand side. So it's going to be integral root of cos raised to the power of 3x over sine raised to the power of 11x. Now what I wish to do is I would like to bring in tan here. So for that I would have to divide this by cos raised to the power of 11x. That's exactly what I'm going to do. So as I mentioned to you earlier, if you have questions involving sine and cos, you will have to bring in tan, do some manipulation so that you have a tan there, and that is the easiest thing to achieve, or I should say towards the solution. So I'm going to divide this by cos raised to the power of 11x, and I'm going to multiply it by cos raised to the power of 11x. So it's all inside the square root. Now this cos sine raised to the power of 11x over cos raised to the power of 11x, this is actually, now we know that this is tan. Now I got a cos cubed and cos raised to the power of 11x. So what I'm going to do is I can cancel the terms here. So I'm going to cancel here, I'm going to cancel the 11 here. So if I were to do that, I would get 1 over, so let me write this down, 1 over, this is tan raised to the power of 11x, and this is going to be cos raised to the power of 8x. Now 1 over cos squared x is, let me place that, 1 over cos x is secant x, so you have a square there, so this will become squared, so you have a 8 there, this will become 8. So this is equal to integral, of course I need to place the dx there, root of, this is secant raised to the power of 8x over tan raised to the power of 11x times dx. Now I'm going to rewrite this further as root of secant raised to the power of 8x over root of tan raised to the power of 11x times dx. Now this would give me secant raised to the power of 4x divided by, this is going to give me tan raised to the power of 11 over 2x times dx. Now I'm going to rewrite secant raised to the power of 4x as secant squared x times secant squared x times dx divided by tan raised to the power of 11 over 2 times x. Now we know that secant squared x negative tan squared x is equal to 1, so from here secant squared x is equal to 1 positive tan squared x. So I'm going to take, in place of secant squared x, one of the secant squared x will be replaced with 1 positive tan squared x. So this is equal to 1 positive tan squared x times secant squared x times dx divided by tan x raised to the power of 11 over 2, so this is tan raised to the power of 11 over 2x. Right, so now what I wish to do is I would like to take tan x to be equal to t, so this would give me secant squared x dx is equal to dt. So this is equal to integral 1 positive, in place of tan x is going to be t squared, in place of secant squared x dx is going to be dt. So this is going to be replaced with t, right? Tan x is equal to t, so this is going to be t raised to the power of 11 over 2. I can rewrite this as 1 over t raised to the power of 11 over 2 positive t squared over t raised to the power of 11 over 2 times dt. This can be further rewritten as t raised to the power of negative 11 over 2 times dt positive integral t raised to the power of 2. I push this is going to be negative 11 over 2. So this has to be multiplied with dt. So over here this can be integrated. This is actually 4 negative 11, right? So that is going to be, let me just place the quantity here, t raised to the power of negative 11 over 2 dt positive, this is going to give me t raised to the power of negative 7 over 2 dt. So I'm going to integrate this is going to give me t raised to the power of negative 11 over 2 positive 1 divided by negative 11 over 2 positive 1 positive t raised to the power of negative 7 over 2 positive 1 negative 7 over 2 positive 1. This is going to be t raised to the power of, now when you simplify this you get negative 9 over 2 divided by negative 9 over 2 positive t raised to the power of negative 5 over 2 divided by negative 5 over 2. Now if you were to flip this, you would get 2 over 9 with the negative sign, right? And then you get the t raised to the power of negative 9 over 2 followed by negative 2 over 5 t raised to the power of negative 5 over 2. Now if you were to take negative 2 out, this would give me 1 over 9 t raised to the power of negative 9 over 2 positive 1 over 5 t raised to the power of negative 5 over 2. Now but my t is tan x, so I substitute it there. I get negative 2 of 1 over 9 tan, right, t is tan x, so this is going to be tan raised to the power of negative 9 over 2 with the x there positive 1 over 5 times tan raised to the power of negative 5 over 2 with the x there positive arbitrary constant c. Now if you were to compare this with the original quantity given on the right side, you see that this is compared with this is exactly the same. So in place of a, so this would mean in place of a you get 1 over 9 and in place of b you get 1 over 5. So that is a good place for us to draw the red line. So this is a beautiful question and we have achieved the solution for this question. Thank you students, we'll see you all in the next lecture.